the audio quality is not perfect because I'm just using the microphone on this machine. But at some point in the course, I'd be curious to know whether that screen capture is useful for back reference. I'm not sure if it is or not.
So Louis, I really like you're having different examples than the examples that are in the ROS tutorial.
Yep.
Because it's another way to look at it.
Yep.
Even if it's not that different, it's another way.
Yeah.
And using real numbers instead of strings.
Right.
Because strings are so easy to handle, and you find actually.
There you go, beating on the computer scientists.
Yeah.
I want you to know that this is a safe place. We're just as happy to have electrical engineers as computer scientists. and poets. Poets too.
Poets.
Yes. So, okay, so it's 13:05. If I'm still talking 55 minutes from now, then just, stop me. I don't think it'll take that long. So with what we covered in Module 1, which was the basic design patterns of how pieces of software are put together with source code, whether it's Python or Lisp or C. You began to dabble in launch files, which enables you to launch multiple nodes in sort of a civilized fashion. And ROS core, which is the switch yard of the whole system, and the transport layer, which is messages and services. That's all great stuff. There's nothing in there that you couldn't do in LCM, the Library for Communication and Marshalling. There's nothing there that you couldn't do with MPI, a message passing interface that is used for massively parallel computing. And advantages and disadvantages of those systems. Advantages is that it lets you modularize on a process level rather than modularize on a library level, different type of module. And so it doesn't preclude the need for library modularization. For example, OpenCV really wants to be a library of a bunch of routines. But then with something like ROS, you can package OpenCV into pipelines to pipeline process things. Just to critique it, none of these systems are at all secure. And so if there is a malicious or just clueless other actor on the system, we saw it this morning, that when somebody else launched a turtle sim, because there was a name clash in ROS core killed mine. And mine went away. Actually, mine didn't. ROS core didn't kill it. Mine said, "Oh my gosh, there's something else in my name. I'm going to go away." And so those kinds of things you need to be careful about from the designer level. And one of the things that the tutorials are weak on is this notion of namespacing. And so one of the things that I'd suggest that you look at is just Google, as you're working on these tutorials, Google ROS names, and the first hit will be names in the ROS wiki. And you'll notice that the topics that we've been using you're beginning to see that they have the same hierarchy that the file system does in a Unix file system with a root at /. And so that same hierarchy holds for the names of nodes, the names of topics, services, and parameters. And so it's very, very useful because if you want to have, say, two instruments that are identical, but you want to differentiate the data that they are producing and you want to initialize them to different values, then the design pattern that you'll use is namespacing. And there really isn't a good ROS tutorial on namespacing. I wanted to make one up before the short course and I ran out of time. But roughly speaking, the way namespacing works is if you, I should give you an example. Checking workspace. So this is just a random launch file that I'm pulling up here. I just want to mention this before we start this module. And I will make a proper namespace tutorial. So this is something that we're going to do tomorrow. You're going to write a package that is called edgemit ROS joy, and it's going to have a node called edgemit ROS joy node, and edgemit, and it's going to run an instance of it, and the name of it is going to be edgemit ROS joy node. So the name in when you do ROS node list, it'll be listed as /edgemit ROS joy node. And if I wanted to run two of these joystick nodes that subscribe to joystick messages and publish a twist message, then the way I'd do it would be I would have two lines here, and I'd say namespace equals joy1 and namespace is equal to joy2. And you can experiment with this while you're doing your packages. And now the node right here that's known as edgemit ROS joy node will appear as the node /joy1 /edgemit ROS joy node. And if I declare my topics, in that node, when I publish topics and if I subscribe to topics, if I don't provide a leading slash in the name that I publish to and subscribe to, then it will automatically inherit the namespace. If I provide a leading slash, then ROS core will say, oh, okay, they really want to publish to that absolute reference from the root, and so that name resolution is the one thing that's confusing about namespace. And so in this web page that I've referred you to, there's this notion of the Stanford robot name. How names get resolved is explained nicely in this little table. When you're asking for the resolution of a name, or you're specifying a name in topics that you're subscribing to. And the way name resolution in namespacing is resolved is absolutely identical whether you're talking about parameters, topics, nodes, and what did I forget? Services. So that's a little parenthetic discussion. And I haven't fully explained it, and I will make a tutorial sometime soon and put it up because that's an obvious omission. There we go. So back to the main event. This next module, Module 2, there's a little exercise in Rosbag, and I think most people were here for the short seminar that I gave about a month ago. Is that true? No? Okay. Well, you'll run this exercise, Rosbag, ROS WTF. WTF looks at your package and tries to decide whether things make sense and whether there's any loose ends. It's sort of like a lint of package. There's a tutorial that just gives you some pointers on where to find things in ros.org. And then we get to the most important thing this afternoon, which is TF. And so TF is something that you don't get with LCM and you don't get with MPI, which are marshalling and transport layers. So TF is a first of all, it's a library. It's a C++ library. And second, it is a utility that has command line interaction introspection tools. And what TF does is keep track of the relationship between frames. And at the simplest level, when we have, say, a mobile robot or an instrument, and we're trying to keep track of the spatial information, this is an example of PR2, which has got a lot of joints. And when you have a fully loaded PR2, you've got something like 50 frames moving around. And so the designers at Willow Garage wanted to come up with a standard way to represent your typical garden variety robot arm, an open kinematic chain that's rooted at the base, or a mobile robot, which is some kind of a kinematic chain that is not rooted at the base, but it has at least one frame on the moving robot. that has a known relationship to a fixed frame, a fixed non-moving inertial frame. And by convention, those of us who do marine vehicles, to our eternal woe, the designers of ROS have assumed a convention for the visualization tools that Z is up in the world, and X and Y are pointed north and east, which is not how naval architects do it, but we're going to live with it. And the thing that we will be doing this afternoon is we're working with frames, and what we're going to see is that TF provides a utility for keeping track of frames that have a hierarchical relationship, and in particular, they have to have a star topology relationship. That there's a star topology meaning there's no loops in the graph. What we're going to do in this exercise, we're going to use the turtle sim. The turtle sim outputs messages, which are its own messages, which are x, y, theta, and some velocities, which are not frames by any measure. And so you're going to write nodes which generate frames from them, and do math on those frames. So the idea here is if a robot is publishing, it knows the relationship between the world frame and its base frame, and it knows the relationship between the base frame and, say, the wheel frames, and it knows the relationship between the base frame and, say, a laser scanner frame up here on the head, then what we have is a hierarchy of frames. It's a three-dimensional kinematic chain. And wouldn't it be nice if we had a utility that would just keep track of all those relationships? And so the basic idea behind TF is that you continually publish the individual frames connecting a star topology collection of frames. And TF remembers those, and by default it buffers for a couple of seconds to look up the exact amount. And you can make that buffering as deep as you want. If you want it to buffer for the last hour, then it can buffer all of those. And when you make a call to TF, you can say, give me the relationship. I've got a laser scanner ping that happened at exactly this timestamp in Unix time. I want you to introspect into all the published individual frames between world and my laser scanner frame at exactly t is equal to time, fractional time, down to a microsecond. And it will interpolate into those transformations and give you the best available transformation. Oftentimes you'll say, just give me the most recent position and orientation of the scanner frame, and there are conventions for doing that. And so you can call on TF to, as long as the sources of the frames are publishing at a decent enough rate, then you can call on TF either from the command line or from your C or Python program to resolve those relationships. And the tutorials will walk us through that. And so these are the two links that we'll be using. And this is an example of something which it's tremendously useful. And I'll just go through sort of the high points of some of the tutorials. RViz, and we'll look at RViz just a little bit, which is the visualization package. So some reading for you to peruse through. And recording and playback of data. I don't think I'll spend any time on this because it's so obvious you can do it. What you're going to do is you're going to run a ROS core, and you're going to run a turtle sim, and you're going to run a turtle sim teleop key, which you already have done, and you're going to drive the turtle around. But while you're doing that, you are going to create a directory called bag files, and then you're going to give the command Rosbag record minus all, minus A. And so it's going to take an inventory at the time that Rosbag runs. So if somebody starts publishing something after Rosbag runs, then it's not going to be subscribed to it. So at the moment, at the instant that Rosbag runs, when you type this, it's going to give you an inventory. It says, okay, I'm subscribing to all these topics. And it's going to hoover up everything on those topics until you kill it. And then you type Control-C to finish it. And then you can, you don't have to kill your keyboard thing, because that only generates a message when you hit down on the key. Then the Rosbag file will have a bag file name, which will be, Rosbag year, month, day, hour, minute, second .bag. When you look into the directory that it's recording, the bag that's currently being recorded into has a temporary ephemeral suffix called .active, and when it closes out the file, the active goes away. And then you can introspect and you can get Rosbag info. It'll tell you what the contents are. And on the back of the cheat sheet, I lost my cheat sheet. You can see there's a little picture for RQT bag on the upper left of the second page. And so, for example, if you're storing numerical data, then it'll show you with little icons, little blips on a timeline where data comes along. And if you have image data, then it'll give you little thumbnails of the images from your camera. And so data that it knows how to display, it'll display for you in sort of pictographic format. And that's a way to sort of browse through the data. And then you can replay the bag. Rosbag play, name of the bag file, will play back your all the topics in that, and you can selectively choose which topics. And so in this tutorial, you're going to record the command velocity, and you're going to play it back. You're going to record your keystrokes in a Rosbag file, and then you play it back, and the turtle will respond to it. So it's pretty straightforward and self-explanatory. And you can record a subset of the data. And there are command line options to using Rosbag if you want it to record and close out a file every minute or every hour, or by size. And the one thing for those who are, the Rosbag is in Python, and for those who are better Python programmers than me, the one thing I haven't been able to do yet, I'm sure I could do it if I take enough time, but I haven't, is I really want a version of Rosbag which will close out the files at the top of the hour, rather than an hour from when I hit enter. So if anybody wants to make that and do a pull request, I'd be insanely grateful. The next module is how to troubleshoot with ROS WTF. This basically looks through your packages or a particular package, and looks and tries to find errors in the configuration of the system. I haven't found ROS WTF to be very useful. I don't use it very much, so I wouldn't spend a huge amount of time on this. This next module just gives you some, tries to orient you in the ROS wiki. And I find that when I've forgotten the syntax for something or how things work, I just usually Google capital ROS and whatever I'm thinking about, and I usually get to the right wiki page. And the only time that I have problems getting to the right wiki page for documentation is, and usually for example, the ROS landing page. This is the main page, and a package landing page for TF. They all have the same structure. Troubleshooting tutorials over here. A little bit about the update. There'll be a link to the Git repository for this, and stack summary. Ignore stacks. Stack is an obsolete concept. It went out in a way about 4 years ago, and the idea of a stack was a collection of packages, and it was confusing because really the problem the stack was solving was dependencies in sort of a backhanded way, or a backwards way. And so with the creation of Catkin, the Catkin build system, which replaced ROS build approximately 4 years ago, stacks have disappeared. And dependencies are handled pretty carefully in Catkin under the build system. And if you do have a series of packages, a set of packages that all kind of want to be used together all the time, then you can make a hierarchical package. And so you can have a package name, sub-package name, source, and then second sub-package name, source. And CMake will work through those properly. It'll recursively work through, and nothing bad will happen. And that's often a design pattern because you often develop things one package at a time, and then you get 6 of them, and you realize, or 8 of them. How many were in the Brady Bunch? This dates me. And then you realize that they belong together, and so you can put them together in a hierarchical package. So that's that. Just want to just give the overview and navigating the ROS wiki. So these TF tutorials, this is where you're going to spend most of your time. You'll blast through these things in a heartbeat. And is the ROS TF tutorials. And these are actually pretty nice. I think Tully Foote, TF was written by Tully Foote, appropriately enough. And he's still one of the leaders of the open source robotics foundation. And if you're interested, by the way, and Tully was one of the, he was probably employee number 6 on the Willow Garage ROS project. Employee number 1 was Keenan Wyrobik, who was a former undergraduate in my lab, who worked in my lab for 4 years and then went on to work in Ken Salisbury lab at Stanford. And Keenan and a colleague of his in Ken's lab wanted to develop a personal robot. That was their mission. They decided they wanted to develop a personal robot. And they also wanted to develop a software ecosystem that would support open source robotics in a way that hadn't been done. They calculated they needed $4 million to do this. And they started shopping around a proposal in Silicon Valley. And in fact, they were way under, $4 million wasn't nearly enough, but they found that out later. And they shopped it around, and surprisingly enough, they found a dot-com millionaire who liked the idea and was willing to bankroll them. And so they created a new project at this guy's skunk works called Willow Garage, and the project was to develop PR2 and ROS. And if you're interested in introspecting more into the origin story of ROS, if you Google ROS origin story, Keenan Wyrobik, my former undergraduate, wrote an article in IEEE Spectrum that was published a month ago, and it's a real hoot because it's got some videos of their, it's got the original slide deck that they pitched to the $4 million project to dot-com executives and mostly failed. And they kept on failing until they didn't fail. And it's also got a video from 2010 showing a bunch of summer interns at Willow Garage that had programmed the PR2. They had the PR2 running for like 2 months at that point. And so they're like, great, we're going to program the PR2 to take voice commands and go to the refrigerator and get us beer. And so they implemented that. And the guy with a scruffy beard is Jonathan Boren, who some of you may know, who is a former PhD student of mine who just recently defended and is now at Honeybee Robotics. And he's in most people's book, the ROS Whisperer. And he's my Uber TA who got me through the first year of teaching this course at Hopkins. And that was the person I was referring to as, I had no idea. Let's ask John. So end of digression. So learning TF. I'm better in C++, and so I've requested that you do this in C++. But if you prefer Python, I have no objection. I just won't be able to help you as much if you need help. And on some of these things, you want to choose the correct version of the tutorial. And we're using Catkin and Kinetic. You may need to install some additional packages, and so we're going to see the turtles running around, and this is Turtle TF is a different simulation, and so I'm going to make sure that I got all my packages loaded. Okay, I've got everything loaded, and by the way, in ROS you end up using a lot of different terminal windows. My own personal preference is Terminator as my default terminal emulator. Because Control-Shift-O gives you this and Control-Shift-E gives you that. And so you can do sort of pop-up windows and manage them easily. So we're going to ROS launch the Turtle TF. And so what this does is it takes keystrokes from this and we're going to be driving one turtle, and the other turtle is going to be chasing them. And I'm sure the designers of this tutorial had great glee in designing this as turtles go chasing each other. And So this was in the Turtle TF package. So if I want to introspect ROS CD, Turtle TF, TF versus TF2. The original TF was called TF. What you're actually using now and is still called TF is actually TF2, but they didn't change the name. So TF doesn't really exist anymore. And so the TF binaries live in op-ROS kinetic. And this is a very thin package. There's no source. But I want to go into the launch file. And we did turtle TF demo .launch. Recall correctly. And I just want to look at introspect into that. What's going on? So we've seen some launch files now. There's a couple things that that I can see is that notice that what's going on here is we're launching a turtle sim, and that's from package turtle sim. The executable name is turtle sim node, so that's the name of there's a turtle sim node.c++ in there someplace, and this is the executable. Then the name of this instance, the ROS node name, is going to be called sim. Turtle sim has a package called turtle teleop key. If you used before, it takes keystrokes and it generates a twist command, which is three linear velocities and 3 angular velocities. It wants to have parameters that gives it a scale for linear and a scale for angular. How it scales so when you hit a key, it's going to the forward key. It's going to give an x velocity of 2 units, which if they are SI units would be meters per second. And the Turtle TF broadcasts so that is a Python package, and what it does is it subscribes to the Turtle's pose, and it publishes a transformation, TF. And Turtle TF2 broadcaster is going to hear. It's going to spawn a second turtle, and then it's going to so it's going to subscribe to the second turtle. The Turtle 2 subscribe to the Turtle 2 pose message. We'll look at the topics. And then the turtle pointer we'll look at that in a second. So let's look at ROS topics here. ROS node list. And so we're beginning to see this notion of namespacing, where there's a Turtle 1 color sensor, Turtle 1 command velocity, Turtle 2 command velocity, color sensor, and pose. And we can introspect into these things with RQT or ROS topic echo. RQT, I've brought in the plugin, which is topic monitor. And so ROS out and ROS ag are errors. And we can see Turtle 1 command velocity here. If I expand it, there's nothing there. But if I put my scope in this guy and type it, then we'll get data. And we're driving the robot. It's a little hard to see in this font, so maybe I won't use that too much. RQT graph. So, so this is the whole data flow of this thing. We have teleop, the keyboard thing, is publishing a command velocity, and then this is being rebroadcast to Turtle 2 TF broadcaster and Turtle 1 TF broadcaster, and they're both broadcasting to TF. So let's take a look at that. And ROS topic list. And so ROS topic echo turtle 1 command velocity. So nothing there until I hit my key, and then I'm hitting my up key and my right key, and so you can see that it's read that parameter. Good question here is, that's not the one I want. This launch file. Notice that it would appear that we've launched this turtle teleop key and we've specified the parameters afterwards. The design pattern and convention in a launch file is that you should not expect that things that appear at the top of the launch file will happen before things appear at the bottom of the launch file. They'll happen at any order, and you should design your code so that they could come up in any order. So there's no ordering in the launch file, and and that's usually not a problem. And in cases, for example, and we'll see later on, if you're calling for a transformation that doesn't exist yet because the node that's providing that transformation hasn't actually been launched because it's somewhere else in the launch file, and things happen asynchronously, there's a call for wait for transform, and so you can wait for it until a transform becomes valid, and then once it becomes valid, then you can start doing things with it. So there are tools for dealing with the fact that things are out of order. Another question that came up this morning is, in a launch file like this, how do I see standard output? By default, if you just, in a launch file, if you just say node, type, and name, then the standard output, which are the ROS debug and ROS warning messages, as well as any printfs that you use, will go to standard error. A copy will still go to Rosbag if you're Rosbagging, but it won't necessarily come to your screen. So when you do a ROS info or a ROS info stream, by default, one copy goes to standard out, and one copy actually goes to the topic ROS out, and then goes to ROS out ag. If you want the output of a program to make it to standard output on your screen, then add this to the launch file. And so this node, this node, this node, and this node are all jumbling their output to the same screen, which for me is up right here. And obviously, they're not very blabberonious. They're not talking much. But their standard output is not connected to standard error. And yep.
So the ROS launch mechanism, is it just basically launching things in the background as if you were to manually do ROS run to something?
It is, only does a little bit more lifting than that. In that the launch file does a few more things than just doing ROS run. First of all, it checks. The first thing it does is it checks to see whether a ROS core exists, and if a ROS core doesn't exist, then it will launch one. And if a ROS core already does exist out there, then it won't launch one. And so there are many times where you want to have multiple launch files, and whichever one comes up first will create a ROS core, and the other ones will inherit that. And the other thing that the launch file does is that you can specify, for example, whether you want ROS. If a process crashes, the node goes down and crashes. Do you want ROS core to relaunch it? So if you add the command, if you add, none of these have it, but if you add minus respawn is sorry, no, not minus here. If you respawn is equal to true, then if that node goes down, it'll get respawned, and that can be dangerous. It's great. It's great when it's good, but it can also be dangerous. So, for example, in Fantasia, there's the broom scene where the broom is casts a magic spell and it carries the buckets of water, and then who is it that there's Mickey the Mouse that says, "Oh God, I've created a monster," and tries to chop it in half, and so there's 2 brooms and 4 brooms. Well, so respawn is equal to true doesn't force them to undergo an exponential explosion, but sometimes when something bad is happening, and your code goes down hard, and it's like, oh, it's going down hard again, and it's going down hard 50 times a second because it's respawning. So use respawn judiciously because it will just keep. It's not smart about it. It just checks to see whether something died and it responds. And So getting back to TF. So we're driving this around, and obviously there's some math being done on the frames. And we're going to run a utility called TF. This is a package in TF called viewFrames. First, before I do that, ROS topic list. So we looked at ROS topic echo turtle 1 command velocity. That was a twist. Turtle 1 pose. This was being shipped out at a prodigious rate, and this is a custom message associated with the turtle sim package. It's a custom message x, y, theta, linear velocity, angular velocity. It's not a 6 degree of freedom transformation that anybody would recognize. It's just a custom message associated with this package. The TF turtle that we're running here, we're running. Nope, and for some reason I lost that. We're running the turtle TF demo .launch, and we saw in that launch file here that it's the thing that it's running is, in addition to the turtle sim, it's running a turtle TF broadcaster, package turtle TF, and this is the name of the executable. And this is the name of the instance, and these have unique names. So they're publishing on TF, those broadcasters, topic TF. And notice what's happening on TF is, we can just see it here. TF is getting all the messages are type transformation. They're timestamp transformation. There's an untimestamped version of this. And so the transform that are being published here, and they're being published at quite a fast rate. The sequence number was used in the early days of ROS. It's going to be abandoned in some later generation. It turned out to not be terribly useful. Timestamp is terribly useful. It's UTC. And this specifies that the broadcaster that has broadcast this TF message, transform message, is specifying the transformation from the world frame to turtle 1 or turtle 2, as the case may be. And the translation, and it's specified as a translation, 3 translational degrees of freedom, and a rotation, which is being specified here in a quaternion. And this quaternion corresponds to 0, roll, pitch, and yaw of 0, 0, 0. And there are utilities for converting between the quaternion representation and roll and pitch and heading. And so if you subscribe to TF, and a TF listener will subscribe to it, then you can introspect into it, and we will do that in the tutorial. That here. So we're going to use the TF utility viewFrames here, and it listens to the TFs for 5 seconds, and then it's going to output a little graphical representation. That's interesting. Hasn't done that for me before. I don't know what's wrong here. Yes, thank you. Yeah, I was in opera, so I couldn't write. Thank you. Try that again. I'm in my home directory. And so let's look at this PDF file that it just generated. So it's just generated me a little map of my geometric relationships. So this is the time that it listened to TF for 5 seconds, and the frame transformations that it heard was frame transformation from world to turtle 2 and world to turtle 1. The average transmission rate was 62 hertz, and it's buffering for 5 seconds. That was the default buffering length. So it gives you sort of a graphical representation, a topological representation, not a physical representation. Physical will be with RViz. And there's that. And RQT also has a plugin, and you can see RQT TF tree will do this in RQT, give you a little graphical representation. And TF Echo is very interesting, and the simplest version of TF Echo. So TF Echo is a executable node that you run on the command line. It's part of the TF package, and basically you choose the source frame and the target frame, and it will give you the transformation between the two. And so if I say ROS run, and anybody who's got their ROS master pointed to my IP, which is 192.168.10.101, ROS master URI. If you point to me, then you can introspect with me. ROS run TF echo. So let's echo from world to turtle. TF world turtle 1. And so once a second, it's going to spit out the relationship between the world frame and turtle 1. And you can see there's a translation. The rotation is 0, 0. And where's my turtle gone to? There's the turtle. And so if I start driving it around, you can see the headings changing now. And TF Echo gives you, shows you the angles in quaternion, radians, and degrees. And I could echo between turtle 1 and turtle 2. And so turtle 2 chases turtle 1, and so their rotation and translation are pretty far apart. But when I start driving turtle 1, you can see that the turtle 1, until it hits the wall, can print out the relationship. So very useful. And now this is our first glimpse of RViz. So we're going to run RViz, and this is kind of a odd syntax. We're going to ROS run in the package RViz. The executable that we're going to run is RViz. And the initialization file that we're going to use, RViz has an initialization file that tells what display things to load up and where to set the viewport, things like that. So it's going to execute Rosbag find turtle TF, and that's going to return the full path name of the package turtle TF on your system. And the reason that they're doing this is that they want it to be independent of whether it's Kinetic or Indigo, the different version of ROS. And so this will do the right thing regardless of which version, whether you're opt-ROS Kinetic, opt-ROS Indigo. And then it's going to append RViz turtle RViz.RViz, and that means turtle. So in your package, if you have a package and it has an RViz subdirectory, by convention, that will have RViz initialization files, just like a source subdirectory or a message subdirectory. And so RViz usually crashes the first time, Gazebo in particular. And so let's see what's going on here. We've got TF, and TF has seen 3 different transformations. And all are enabled. We've got turtle 1, frames, TF, marker scale, 2, update interval, and so we go up here, move TF over here, move turtle over here, always on top. Get rid of that, and start driving around. And there are our 2 frames for the turtles driving around. And now we've got 3-dimensional introspection. And there's a timeout being set here so that once the frame data gets old enough, they won't be displayed anymore. And turtle 1, turtle 2, all enable, marker scale, update interval, 0. Frame timeout right here, frame timeout 0. And the frames will stay indefinitely. And so you can see what's going on here. We're getting a 3-dimensional introspection. And with the mouse button, I can scroll in and out. If I grab hold of it, I'll tilt it. If I shift grab hold of it, then I'll translate it. And if you want to get frustrated, try running TF with just a touchpad. I don't recommend it. So if you're going to be using RViz for any length of time or Gazebo, I recommend that you have a mouse with a wheel, a 3-button mouse with a wheel, and life is a lot easier. Just the touchpad is a pain in the neck. And if you're old and decrepit and arthritic like I am, the touchpad isn't really an option anyways. So this gives you an example of where the ROS ecosystem provides introspection tools that are more than just chasing the data. You're actually getting a 3-dimensional visualization of the data. And we won't get into it very much more, but the one thing that we need to get right here is we need to tell Gazebo what the fixed frame is. And so this initialization file has already done it. The fixed frame is world. And TF is being shown here, and a grid is being shown just so we can have some visual orientation on this. And if we have other things that we want to display, we just click on Add here, and notice that there's a whole bunch of things that you can display. You can display axes, camera, depth cloud, fluid pressure, occupancy grid, 2-dimensional map, marker array. Marker array is, for example, if you have a laser scanner and you want to have a line of markers where the laser scan was. Odometry, there's a message type called an odom, and if you publish odom messages and you select one of these things and you insert one of these things in and you connect it to the right topic, then the odometry track will appear magically on the screen. And similarly, what we'll do tomorrow morning is you can insert a type which is called a robot model. And a robot model will load in a universal robot description file, an URDEF, and it will display the robot model here, along with its color, shape, and other properties. And this is not a simulation. This is a display engine for visualizing data, and so not to be confused with a simulation. And so there are display types for a lot of standard things that we want to do. So a point cloud, so you've got a RGDB sensor that does both range in a 2-dimensional range and also a 2-dimensional image. Well, it'll display this as a patch, as a cloud of patches, and it'll do texture mapping. So you take an image topic and a depth topic and select those into the display, and you get a 3-dimensional display of whatever your sensor is reading. Range sensors are useful. I'll probably try to demonstrate that tomorrow by putting an ultrasound sensor on one of the edge MIPs so that you can kind of hold your hand in front of it and it responds. But for now, this is just an introduction to RViz, and I found RViz to be a very useful tool. And so this next demo, any questions about RViz? So the programming assignment here is pretty straightforward, and as in all these tutorials, they really give you the code. And we're not using ROS build, we're using Catkin. And they're going to ask you to create a package called Learning TF, and it's going to depend on these three packages: ROS CPP, ROS Python, and TurtleSim. And you create this in the source directory of your workspace, and ROS CD to this. And this is an example of a package that's going to. Let me go back here. Get the TurtleSim running. RViz. So notice that we have ROS topic info turtle1 pose. So it's of type TurtleSim pose, and I can say ROS message info capital pose, and it'll tell me that that the TurtleSim is the name of the package, pose is the name of the message type, is consisted of these things. If I wanted to know info on geometry, messages, what are the geometry messages? Oh, there's a whole bunch of them. Geometry message transform. That consists of an XYZ and then a 4 vector, which is the quaternion, or a transform stamped. It consists of the header, and what we were looking at in TF was transform stamps with the timestamp header, the sequence number, which isn't used anymore, and the a 6-degree of freedom transformation in using quaternions to avoid the singularities associated with Euler representations. So RViz RViz doesn't know a thing about TurtleSim, and it's probably never going to know a thing about TurtleSim. And let me make my marker scale 4 giant markers so we can see them go away. So when I drive around here, RViz, things didn't work there because I'm going to do a clean start here. I'm going to start my packages, and that starts a ROS core, and RViz I'm going to run, and it's going to subscribe to topics, and everything's going to be good. If you want, what was on top? Okay, so that's working. And RViz TF marker scale 5 big markers. Drive around, frames are there. So RViz doesn't know about the message type pose, which is unique to the Turtle package, but it knows about transform. And so whatever internal representation your system may use, if you somewhere in the system, either internally or externally, are able to publish transforms, then bam, you can tie into all these other things. It doesn't mean you need to use them as your internal representation, for sure not. and many times you may not want to, for very good reasons. But if you want to visualize them, then if you can publish transforms, then you can make use of all these utilities. And so this is an example code that there's two pieces of code that we're going to try to write for this section, and Control Shift O. Oh no. And so ROS, Catkin workspace source, learning TF. And so we're going to just basically make a launch directory, launch, sorry. And in this series of demos, they're going to ask you to create a launch file called startdemo.launch. And then they're going to ask you to add things to it twice. And so in my directory, I've just made 3 versions so that I could play them back to you. And in the source directory, you're going to make a turtletf broadcaster, a turtletf listener, and a frame TF broadcaster. And what these are going to do, the turtletf broadcaster is going to subscribe to the turtle pose message, and it's going to publish a TF that represents that pose. The turtletf listener is going to listen to the two things, and it's going to give commands. It's going to listen to the frames for the two turtles and give commands to the turtle behind to drive towards the turtle forward, doing matrix math. And the frame TF broadcaster is a way of it's going to basically subscribe to a turtle frame, and it's going to publish an additional frame. So if the turtle is the base frame, and you have some sort of a moving arm on top of the turtle, it's publishing the relationship, and so we'll see a frame that follows the turtle around, but at a distance. And initially that can be constant, but there's also, if you do the whole tutorial, it'll be time varying, so it moves around. And that would be the example of if you had, a sonar or some other kind of sensor that was on a pan and tilt platform, and you wanted to track that. You've got the frame of the vehicle, and you've got the Who's He What's It sonar on the pan and tilt platform, and you want to track all that stuff. And so the code here is not particularly clean when it comes to geometry, for which I apologize. I didn't write it. It's just a little sloppy and sort of too many lines. But so this is the turtletf broadcaster, and we need to include TF transform broadcaster.h and turtlesim pose.h. And notice the convention. We're using the same convention. This is a header file, transform broadcaster.h, which is part of the TF package, and so that's how we access it. And we want to include the custom message type pose from the turtlesim package, and so use the same syntax, and it'll pull it from ROS appropriately. And the main down here is we're going to do ROS init with myTF broadcaster, and ROS error, and then we're going to subscribe to the turtle name pose topic, so turtle 1 pose or turtle 2 pose, and we're going to subscribe to that and we're going to call the pose callback function. And pose callback gets the pose message, which you recall is x, y, theta, and 2 velocities, and it's going to it allocates within the function a static TF transform broadcaster. So TF, and this is the syntax, you're going to allocate an object which is from package TF, and the transform broadcaster is the object. You're going to allocate a transform from the TF package, which is a frame, and then you're going to set the origin of the transform. In the callback function, when it's called, it gets a pose. So this is the message that it gets, and you've already seen this when you subscribed. So this is the incoming message, and it's a pose, and it's got an X, it's message X and message Y, and so we're going to set this transform translation vector to X and Y that came from this pose. And then we're going to do sort of we're going to allocate a quaternion, and then we're going to use the quaternion member function set RPI for roll, pitch, yaw, and we're going to drop message theta into the yaw, or heading, degree of freedom. And then we're going to call transform.setRotation and give it that quaternion. So it's a little confusing. You'd rather have a single I would have provided a single function up here that did all 6 arguments at the same time. But then again, I don't have a CS degree. And then we're going to send transform. And so we're going to send transform, and this is we're going to construct a stamped transform. Up here we constructed a transform which was not stamped, and we saw the 2 message types earlier. They differed in one of them had a header with a timestamp on it. And so this TS transform is just got the XYZ at quaternion. And then we're going to, inside this call to send the transform, we're going to construct a stamped transform, and we're going to construct this stamped transform from the transform that we set here, the current time, and this is the first time to our first example of calling to ROS time. So the ROS time package has a bunch of utilities, and this is going to give us the time in UTC. And if you Google ROS : time, you'll see that there's a whole bunch of calls that you can use for transforming time and doing addition and subtraction. And the transform needs to know the transformation is from one frame to another frame, so it's from world to turtle name. And that's what we were seeing here when we said echo TF. So that's what these transforms were. They were being broadcast by that code that we just looked at. And there's 2 instances of the code running. One is running and broadcasting for turtle 2, and the other one's turtle 1. And that's why you see this thing jumping back and forth, because there are different headings. They're at the same position, but different headings. So you go through that. I think it's pretty self-explanatory. The usual mumbo jumbo with CMake, add executable, add target link libraries. And this shows you how to set up your launch file to launch 2 instances of this. And may not be obvious, how did we get 2 turtles here when we just ran 1 turtle to sim? This package will contact turtle sim, and it'll spawn the second turtle. So that's how that gets going. And then running this will look like this. So when you write that code in the launch file, you'll see this. And so what else is going on here? In the launch file, we can introspect here, ROS run TF echo. We can introspect with them. And now to actually use the transforms, which is being done here, but they haven't shown you the code yet, is we're going to write a TF listener. And so this is a function that's going to subscribe to the TF topic and do something with that information. And this is the program that actually causes turtle number 2 to chase turtle number 1. And so it works like this. The way this works is it's a main, and you do ROS init, my TF listener, create a node handle, and this is when you run this code, this is what spawns the second turtle. So ROS service is going to wait for service until a service spawn becomes available, and then ROS service it's going to create a ROS service client add turtle, and that's going to be it's going to basically it's queuing things up so that you can make a spawn call to the turtle sim. When the turtle sim first runs, there's only one turtle there, and when this program runs, with this service call, it spawns a second turtle. That's where the second turtle comes from. And then it's going to advertise that this node, the transform listener, is going to publish a turtle2 command velocity. So it's going to give a command to turtle2. Our keyboard is giving the command velocity to turtle1. And then it's going to create the transform listener right here. And a TF listener is going to subscribe to the TF. Once you go past this line, the listener is subscribed to the TF topic. It's listening to every single TF that's out there, and it's keeping track of them. And it's buffering them. Default, I think, is 5 or 10 seconds. I can't remember which. I have to check. And by default, it buffers a modest number of seconds. You can have it buffer hours if you want, if you're willing to have the memory cluttered up. And so it's doing this already. It's assembling things. And then while node OK, we go into a loop here. And the loop is going to sleep and run at, I think, 10 hertz. Yeah, ROS rate 10. Again, I wouldn't do this here. What I would do is I would do a timer callback function and put this stuff in a timer callback, and I'd do a ROS spin. So I think this is kind of sloppy. Because the TF listener right here is counting on callbacks to listen to TF. What the code is doing is it creates an empty transform here, and then it does a lookup transform. It's doing a lookup transform and it asks for the transform from turtle2 to turtle1. ROS times 0 means that it is, we want the most current transformation, most recent one that you have. And if you want something other than the transform, you can put different arguments. Oh, no, sorry. The transform is the, transform is the place where it's going to put the results here. And this is written in a try-catch configuration, which I wouldn't really recommend. A better design pattern would be to, in listener, you can first call this exact line, and you can say wait for transform, and it'll wait for that till that transform is valid. So if when your program runs for the first time, if that transformation hasn't been resolved yet, it'll just wait around for say 5 or 10 seconds, and then it'll do a lookup transform. And once the wait for transform returns true that the transform exists, then you can do a lookup transform without generating an exception. And what is in this example case, they just said went for broke. Let's look up for the transform. If we get an exception, then go to sleep for 1 second and try again. I think it's a little more sloppy. So it gets the transformation from turtle2 to turtle1, and then it creates a turtle sim velocity message, which is just a twist. Oh, sorry. Actually, we're looking at the wrong version of code. Sorry. This first version is for pre-hydro conventions of the turtle sim. The second one down here, which is almost the same. The only place that the only difference is right here, is that it uses the turtle sim now uses a geometry message twist, and this gives a command in the x velocity in the turtle heading velocity that's proportional to the difference in headings between the two turtles, and it gives a command to the turtle2 x velocity that's proportional to the distance between the two. So little geometry, and then it publishes that command velocity message. And so the two publishers and this one listener that's publishing the command velocity are what's going on here. And if we drive this, you can see we're still driving. And if we look at RQT plot, that's not what I want. RQT plot is kind of, it's for plotting things. It's actually not a great utility. I wish somebody would write a proper version of RQT plot. Okay, so so we've got a lot of things going on here. Most important thing is that the teleop is this is the keyboard thing that I type keystrokes into, is sending twist messages to the turtle sim. Here's turtle sim here. Sim is this guy, and then the TF listeners, the TF broadcasters, there's two of them, Turtle 1 TF Broadcaster and Turtle 2 TF Broadcaster, are subscribing to the Turtle 1 and Turtle 2 pose, and they're publishing to the TF topic. But they're publishing world to Turtle 1 and world to Turtle 2 frames. The listener, which was the last code that we looked at, is publishing to the a command velocity to sim, so you can see the command velocity going back here to sim for the Turtle 2 command velocity. So that's the whole data flow. So that's what's making this thing, that's what's driving this thing. And you should have shot me 15 minutes ago. So that's basically the tutorial, is to familiarize yourself with frames. And the code is pretty well explained, I think. And the one thing I won't go over now, because I'm over time, and I think it's really important to have your time, is you'll do one more piece of source code where in Turtle 1 you'll write a publisher which publishes a frame called caret, which is attached to Turtle 1 but apart from it. And initially you'll make that will be a static frame, but if you want to do the additional exercises, you can make that time varying, and it will do what you expect. So that's the design pattern for handling transformations. I think it's actually rather powerful, and this is actually a tiny little bit of code. And TF2 had an innovation, which is TF2 allows you to publish static transformations as well as dynamic transformations. So if you have some reason to want to be very parsimonious about what's the data that's sloshing around in your system, and you have a lot of static frames, then you can make use of static transformations. That's a detail that you can read about. Questions? Yes, last thing I'll mention this. If you get to this, great. I think you probably all will. So this is a better design pattern where in this code we're doing a wait for transform first. In this code snippet, we're doing a wait for transform right here. We're waiting for the transform from T1 to T2 to become valid, and we're going to wait for a total of 1 second. You want the transform. You're interested in the transform that's now, and now is resolved here is the current time. And once this returns, it's going to return either because it times out after a second, or because the transform becomes valid, and then you can do a lookup transform. And if that fails, then you want to have a catch. And this is the last thing on the time travel is this creates a timestamp which is time now 5 seconds ago. And so when you run your code with this in the lookup, Turtle 2 is going to follow where Turtle was 5 seconds ago, because we're waiting for a transform. We're looking up a transform. We want the transform from Turtle 2 to Turtle 1 past, which is time now minus 5 seconds. And so when you hit the keyboard on the system with this code in place, you hit the keyboard, Turtle 1 goes driving off, nothing happens for 5 seconds, and then Turtle 2 mobilizes, because the code that's computing the transformation and giving the command to Turtle 2 is looking up the transform that was valid 5 seconds ago. And obviously, this is going to have some startup problems when you run the program for the first time. This can't possibly be valid for the first 5 seconds the program is running, and that's why it's important to have wait for transforms. This is useful for the fact that you get multi-beam data from your delta T, and you'd like to georeference it. You know the position of your delta T multi-beam sonar on your vehicle, and you figure out your vehicle frame and the offset, and you know from your measurements where things are. And if you take the multi-beam data from the delta T and you publish it as a scan topic, and you name the frame properly associated with that, then you can pop up RViz, and you can get a scan visualizer, subscribe it to that topic, and then suddenly you get a carpet of a dot cloud as you drive your simulation or your real vehicle across the seafloor. So, I'm taking too long? Questions? Complaints? Suggestions? All right, go for it.
Just one other quick administrative comment. Nobody else should be in the room. So subject to your own feelings about police security in an unlocked room, you're welcome to leave stuff here overnight. Wouldn't leave a laptop.
So I would say, let's either reinstall the ROS or
Well, what about the one?
you can lose it at 5. Can you do 5? Can you do RPG Plus is going to be
I just want to be sure.
Yeah.
Nothing plus actuation 5. Make sure
Sorry, do you still have the signage? Yeah.
How would that be done?
when you write an order and you specify a bunch of things, most of those end up being fat transmissions.
So that's how.
So where they usually arise is a whole bunch of transmissions that are all fat transmissions. And you're understands that static
So I can still request it. So there's no way to use the publish, correct?
Somebody needs to publish the static transmission.
But in defining
You're in.
that you're only going to, right?
There are occasions when I want to publish static transmission. You want to just put a camera on the side. So you just don't have static transmission.
So, do we have this discussion about the? Would that be beneficial?
What I'm doing is offering is
You just need this right now to be selected. We have conversations. Yeah. Well, it's going to rotate in place.
Yeah,
variables get stuck and stop. Yeah, so what is the vision?
It's work on some of those comments.
Yeah.
Very good for us, I'm sure, and it's more than what I have.
I think it makes, I think you learn more if you use tutorials first.
Yeah.
Because otherwise, you just capacity code that works, that's like, okay, that's a good requirement. Yeah, so if you take time, I think it's worthwhile. It does happen occasionally.
So before we
Usually you get a zombie, so if you're trying to run off a press board, and UPS passes. I haven't seen that.
No,
Back in the dark ages, they used to do a lot.
I think they just control C it and stop, so it closes the room.
When I'm having trouble filling it, what I'll do is use a control Z to put in the background. 10% one. That was the first job. Well, it depends on what you want to do. If you just want to play back the commands, then all you need to record is the command block suite.
Well, what about the things in the background?
Let's do.
This is just command block.
Could we do a Roslaunch? Well, do a Roslaunch post first.
And I bet
Do a Roslaunch post. Can you do a Rosbag info?
We can just close.
So,
Close and do anything.
pose is the output of the signal. So pose is X, Y, heading, and X velocity and heading velocity.
But I won't move it to the.
So both, the simulation is publishing pose, and it's subscribing to a twist, which is 3 linear velocities and 3 angular velocities. And it's normally subscribing to the name of the turtle, CNC, and that's a type of standard messages, geometry messages.
Cool, okay, cool, can we get the close on?
That's right. But you can see that there are introspection like you can introspect to the back pretty easily. Figure out what's in there.
I was wondering if there's some sense of like a minimum necessary report for the audience, but that's.
It really depends on your application.
Okay.
If there's no
There's no like flag for those.
No, where values become particularly useful when you're developing an instrument or a vehicle or something, and you have limited access to the hardware, and so it's an output from it, it's an input from it, and then you're making some sort of processing for it, and then the police come along and take it away. And, like, you're not going to see it for 2 weeks. So if you've got some validated, you can play back and you can work on the upstream stuff without actually just the hardware.
Yeah.
Or alternatively, if you've got a simulation for it, you can plug it into Zebo, then it can give you big data. The advantage of Zebo is that you actually know the ground truth data in addition to what your sensor data. Introspection is important.
How are you finding?